Maybe.
Hello, welcome to Sunday Science Q&A, and today it's going to be predominantly astronomical, and we thank you very much everyone for sending all your questions in as well. We've got loads of questions to get through. Helen is with us as usual this week. I'm sorry I wasn't with you last week. That was over various different issues or something or other, which I'm not going to bother telling you about. And we are today joined by I will give you all the announcement of their full titles shortly, but by Chris Lintott, who was on one of the very early Sunday Science Q&As, and I'm really pleased to have for the first time Dr. Tana Joseph as well is going to be joining us. A few things to tell you. One of them is, well, I've actually got the list here. I might as well just read it out. Next week, I think there's not going to necessarily be a Sunday Science Q&A because we did something with the Blue Dot Festival, which we're not allowed to announce yet, but more than likely via Cosmic Shambles, there will be an event that we did for Blue Dot Festival, which of course is not actually physically happening within the field near Macclesfield, as I like to call Jodrell Bank, and that's how they love it being described. Yeah, we just call it the field near Macclesfield, and so it's not happening there, but there are lots of Blue Dot events, and we have done a very special event, very special Blue Dot based event. Also, this would have been Latitude weekend, so again we would have been doing lots of different things. Was it Snow Patrol that I'd have been avoiding? I'd have probably been avoiding listening to Snow Patrol this weekend, but in fact now it's been much easier to avoid listening to Snow Patrol because Latitude's not been going on. But I will mention that the Teenage Student Neuro Hurdles, which is that's Suze Kundu, Dean Burnett, Susie Gage, and Pete Etchells, and there's also the latest episode of Genetic Shambles is coming up, or indeed is up, and we've recorded that. And on Tuesday night there is also a Royal Academy of Engineering event, and Helen Czerski is presenting that, so I might ask her shortly what's going on there. I think that's all you really need to know. There'll be more show and tell this week. There'll be some new book shambles. There's also a Richard Holloway book shambles. Richard's written another fantastic book. Richard, the former Bishop of Edinburgh, who has a very interesting journey with his faith, and I suppose now his kind of godlessness, really. His book Godless Morality was certainly one book which helped him leave the church, and the church perhaps give him a little nudge as he went as well. So anyway, we are joined today, as I said, by a fantastic group of people. First of all, I'm going to go to normal co-host, last week's solo host, Helen Czerski. How are you doing, Helen?
I am all right. I am with a different background today, but yes, all good. I've just been cycling. I've just been in a rush, so I'm say that again.
You seem to have the backdrop for Honey, I Shrunk the Kids, as far as I can see.
Have you been? Why not? I think we should work our way through the films, frankly. And next time, you see, something is arriving tomorrow, which will make my next background extremely exciting, and I'm very excited about it. And I will let everyone guess what it's going to be, because I'm very excited.
Now we'll start off with your. You have a show and tell. You've cycled. You were slightly late because you've cycled to this week's show and tell. What have you got?
Well, I have a small show and tell because I had to cycle with it. So what I have look very boring here. They're little orange ping-pongy ball things, but this is the frontier in glacial science. So these are among the random bits of science I still have on my shelves. And inside each little ping pong ball thing, here's all it's a tiny bit of electronics. You can see there's all these tiny little board in there with chips on it, and they're all embedded in this resin. And the reason for these existing is that we do not know what happens inside glaciers, and it's quite an important question, what happens inside glaciers. These are places where there's piled up solid ice on land. It's very slowly flowing out to sea. And the thing is, they have tunnels in them. So water melts up on the glacier, it seeps through the glacier, and it comes out the other end, and nobody knows what happens in between. So these were built to drop in at the top. And the hope was that they would go all the way through the glacier and come out at the bottom, and they're actually glow in the dark. They've got special glow in the dark stuff, so someone could find them, and then you could look at all the data they collected and see where they'd been. Now, in practice, so this was done 6-7 years ago now, I think. And what happened was that we put loads of them in at the top of the glacier. This is somebody else's main research project, and none of them came out the bottom. So these are the spare ones, the only ones left, the ones that didn't make it out. So somewhere inside that glacier, probably frozen solid now to pop out of the bottom in 100 years' time. There are lots of little orange balls like this that will probably act as like archaeological finds for the glacial scientists of the day. But the nice thing about these is they're really small and cute, and it's a place we can't go. I mean, the rivers on these glaciers, it's like plunging waterfalls and enormous great big caverns. Even Indiana Jones wouldn't go near it. So humans are not going to go down there. They're full of rushing water, which is all at 0 degrees. So yeah, these little orange balls, they're sitting there with data on them. They know, and we don't know because they're still stuck inside the glacier. So I've got the only ones left. Another one of these may not be touched by another human for 100 years. They're going
to be the kind of AI that evolve into the super robots that eventually rule the Earth in a more benevolent fashion.
Well, yes, I think so. But I think they might join up with the ocean and become kind of ocean robot gods or something. I don't know. Let's find out.
Oh, well, that's beautiful. It's and because it is such an intriguing and very small, well, not very small, of course, nowadays in the world of nanotechnology, but bulky almost. But engineering. Can you tell us about the engineering event?
So the engineering event is exciting. There is a big national engineering event, the McRobert Award, and it's given out for all kinds of exciting things. And obviously they would normally have a big showy dinner and all kinds of posh things like that, but instead they've got us. So I will be hosting a panel discussion that evening with the winner of the McRobert Award and various other people. And the topic is really interesting. It's about engineering of the future. And the nice thing about all of this engineering is that I'm not going to reveal all the secrets, but as the panel will show, we think about the engineering of the future as being swanky spaceships and, fusion drives and all this kind of Star Trek-y stuff. But a lot of the necessary engineering for the future is wonderfully mundane in some ways and brilliantly inventive in others. And we're going to be digging right all into that. Who should be the engineers of the future? What kind of mentality are they going to need? And what are they going to be engineering? And so I have been speaking to the panelists this week, and they are a fascinating bunch, really. I know you'd expect me to be biased, but and one of them is the most enthusiastic man about diggers I have ever met. And that is all I'm going to say. Genuinely made my day, that conversation. So come along and join us on Tuesday. It's an hour, I think it's 6:30 in the evening, can't just remember the time. But all the stuff will be online on the Cosmic Shambles network. And yeah, it will be a fascinating discussion. We've got some really brilliant guests, so do join us.
So that's it. It's 7 p.m. starting time, and that's free for everyone to watch as well. Thank you, Helen. That's brilliant. We've got loads of questions coming in a moment. Now we're joined, as I said, for the first time by Dr. Tana Joseph, based at the University of Manchester, Newton Fellow, Jodrell Banks Astrophysics. Now, you said you had problems with some issues of what you can show and tell.
Yes. Hi, everyone. Hi, listeners. Hi, panel. Thank you for having me. Super excited to be here for the first time and hopefully not the last time. So I am an X-ray astronomer. And that means that the telescopes I use are in space because our planet's atmosphere doesn't allow X-rays to penetrate down to the ground. So in order to detect X-ray emission or X-ray light coming from various objects in space, we need to put these telescopes outside the atmosphere and have them flying around the Earth. And so I often get lots of requests for photos saying, I'm sure you have a beautiful shot of you with the telescope. And then I have to, break people's hearts and say, well, the telescopes I use are entirely space-based. And in fact, there are a couple that I use now that are radio telescopes which are on the ground, but one is in Australia, in the outback, so extremely unlikely that I'll ever go there. And the other one is in South Africa and also in a semi-desert arid region that takes a few hours drive to get there, and you need PPE and lots of permission signs to be there because it's in the middle of nowhere. There's no hospital if you get bitten by the snakes or scorpions that live there. So it's all a bit inaccessible, which is why we built the telescopes there. There's no interference. So yeah, I don't have a lot of photos, or if any really, of me with the telescopes that I use. So instead, for my show and tell, I am going to tell you a bit about myself personally. I have two items. So one is my bear. It's a little wooden bear carved Some friends in California gave it to me, and it's a carving of the bear of the state flag of California, the Republic of California. And her name is Belinda, because what other name could she possibly have? And the reason that I got this as a Christmas gift is because I love bears. And I try and bring them into all of the public talks, that and Predator, separate thing. Maybe next time I'll talk about my Predator obsession. But I love bears. And of course, there are two constellations in the Northern Hemisphere named after bears, Ursa Minor and Ursa Major, the big bear and the little bear. And they are not visible in the Southern Hemisphere where I'm from. So there are some of the constellations that you can't see. And so being African, being from the Southern Hemisphere, the reason I'm super into bears is because we just don't have them. Africa has and is famous for all different kinds of animals, marsupials notwithstanding. And we have all these kind of like famous, we have the big five, and we have classic things like a giraffe, which is entirely unmistakable. But one of the main land apex predator we don't have is bears. And so my sister and I, we got really into bears. I am evangelistic about bears, and I've convinced one of my lifelong friends to also jump on the bear train. So I get to look at this every day. It's on my desk by Belinda.
I love that because it's the best example of the grass always being greener ever. Yeah. Anybody who lives in London would love to see a zebra. The sorts of things that are common perhaps in South Africa, and you have zebras everywhere. You're not interested in those. It's all about the bears. I love that.
Yeah, absolutely. And I know it seems like I'm being a bit mean to the African animals, and I adore them and they're all fantastic and great, but it's always you always crave the thing you can't really have, and for me that's bears. And the other bit, more related to our topic today, my other bit of show and tell is a Hello Kitty astronaut that I got from one of my sisters, and this little toy embodies so much of what I love about the world. So it's space-based. It's a little cat in space. It's mostly pink, which is my favorite color, and it was given to me by one of my siblings, and my siblings are my favorite people in the whole world. And my sister was holding on to this for me. She got it from a Happy Meal that she purchased during the World Cup that happened in South Africa in 2010, 10 years ago already. So there's a lot of significance and a lot of importance on this little Hello Kitty. And it's also just really adorable and tiny. And so these are on my desk. They travel the world with me wherever I set up shop for my next job. And then just a reminder of my family, of space in their own different ways, the stars, constellations, etc.
That's wonderful. Thank you very much. I like that. Yeah, just that bit there. Two objects. Those are the objects which carry all of your kind of, your sense of the other people, that the connectivity. I think connectivity is such an important part of Svalbard's a good place to go to meet bears, isn't it? As far as I remember, if you're going to pop to the seed bank, I was meant to do a gig at Svalbard till someone actually worked out how much the gig was going to cost and the size of the potential audience due to the minute.
Very small.
But someone said, yeah, you'll enjoy constantly going, the bears are coming, get back in. What are we going to see from? I hope we're either going to see a Cindy doll that is perhaps a subaquatic Cindy doll. Is that what we're going to see?
I'm the Hello Kitty astronaut for starters. Secondly,
great,
you would have loved Svalbard. One of my favourite things is Svalbard Museum, because I've been there to visit the people who have the radar studying the Northern Lights. And Svalbard Museum is 1/3 Arctic animals, stuffed walruses, that sort of thing. 1/3 history of Svalbard, bits of old mining equipment. And then they didn't have anything to put in the rest of the third. So anyone who lives on Svalbard can have a little display in the museum. And when I was there were a couple of parents who had taken all the stuff from the bedroom of their daughter who'd gone off to university in Oslo and just put it in the museum. So that they could have the space in their house back. So I think this is a brilliant example of what a museum should be. And for a moment, it made me forget that there were heavily armed polar bears outside the town wanting to eat astronomers.
But it is a bit like that, isn't it? So I had a friend who, a few years ago, they moved out, they had to live overseas or something, so they just left the house and they came, they lived without all their stuff, and they came back and they said it's like walking into a museum of meat.
That's right. It's
because
disturbing.
it was suddenly sort of distant from them, but obviously it was all their stuff. And it's
well, I felt this. I
space
went back to
consumption.
my office for the first time. It was like a museum of what I was doing in March, but I'm supposed to be doing show and tell, I think. So it's perhaps a bit more. I'm completely obsessed with Comet Neowise, which is just beautiful and which we will talk about. But I've got this old book that I found a while ago. This is The Story of the Heavens by a guy called Robert Ball, who is an Irish astronomer who ended up in Cambridge. He was a mathematician. His most important book is called The Theory of Screws, and I highly recommend it if you're interested in 19th century mechanical geometry. But he also wrote, he gave a lot of the Royal Institution Christmas lectures. He wrote for a public audience, and this is one of his public books. So I thought I'd see what he said about comets. And I really like, what I want to show you is this print of the comet of 1882. Sorry, 1882. No, 1882, which is this beautiful thing. But what I love about this print is this is a book from 1900, but it's a very suburban scene. You've got a comet above the rooftops, and it's in about the position that I saw Neowise a couple of nights ago, low in the sky. And so here we are. So 1882 was a great comet. There is an argument going on about whether this comet Neowise that we've got in the sky is officially a great comet. It's certainly quite a good comet. But I love the fact that Robert Ball was enjoying a view of it of something similar, 138 years ago.
It's also, you don't often see a print in books which is so dominated by just darkness. Whereas, print normally, I imagine there may well have been arguments for that, because normally they say, look, we're going to have to make so we've got to want lots of detail, but that just see the darkness, the very just there that faint illumination of the rooftops. A very beautiful print.
Yeah, I should have said it's from Streatham. So it's a drawing of the view from Streatham, and it's got a couple of stars in there. So it's a sort of scientific drawing. He's tried to show the comet that he's also got the place. So I don't remember seeing that before. I'm really pleased to have found it. The book, by the way, was somebody's school prize, so it's nicely bound with the logo of King's School somewhere in Shropshire, and Cyrilio William Watermow won the prize for mathematics in 1901, and then I've got his book now.
What makes a comet a great comet instead of a good comet? Is there criteria for that?
Yeah, so people. Sorry.
Yeah, so it's bright. It's kind of its own brightness. So if it's a great comet, then it needs to be bright enough to see by the naked eye, etc. And I certainly have seen Neowise with the naked eye, but I can imagine that it's on the fence. So, for instance, if you could see, I'm sure if it was bright enough where you could actually see the two tails, for instance, with the naked eye, then I reckon there wouldn't be an argument against that. Yeah,
I reckon my working definition is if people who aren't into astronomy go, what on earth is that in the sky, without even looking, then that's a great comet. And there have been comets, though, some 19th century. The 19th century seemed particularly blessed with great comets, but they certainly had comets that were visible in daytime.
Is there a level above great then, or is great as good? Is great the highest you can be as a comet?
So far, I think great is as good, but daytime comet is pretty good. So if you're a comet that's so bright you're visible even in the daytime sky, that's quite impressive. And then I guess there's. But comets are funny because they become famous for other reasons. Like people think people have heard of Halley's Comet. And I think people always expect Halley's Comet to be spectacular, but it when it came past in 1986. Its last visit to the inner solar system, it wasn't a great comet, and it will be even worse next time, because of the way the geography was.
Last time you were great, and now you've been relegated to quite good.
but quite well known. So Halley's Comet's still got that star quality. People want to see it because of of the name, not because it's churning out the hits. Still,
let's start, in fact, with some questions about Neowise. Tana, can I start with you? Andrea would like to know, where is Neowise going for the next 7,000 years then?
It is whipping around the solar system. So I had to double check this, and I won't lie, I've got the Wikipedia page up in front of me in case it gets very technical. But basically, the Neowise it's barely on a closed orbit, which means that we're going to wait a very, very long time for it to come round again. So thousands of years, so on the order of about 5,000 years. So it's going to be, traveling all the way out to the far reaches of the solar system, and then it'll wind its way back to the inner solar system again and come past Earth. But it's, as far as, even you could think of it on a human, not just on a human lifetime scale, but a human civilization time scale. We're not going to see this bad boy again.
So when will it be the end of Neowise? I presume eventually, over time, through attrition, etc. There is a point. When Chris, what is lifespan?
So comets do break up. So most of the time in the orbit, they're perfectly safe. You have to think a comet is basically a dirty snowball. And so most of the time when it's out in the outer solar system, it's frozen, it's static. But every time they come in and they grow these tails, it's because they're evaporating. So one way a comet reaches the end of its life is that it can break up. And actually, people were very excited about Comet Atlas, which was coming in a few months ago, and that was supposed to be bright, but it just broke up as it came in, and you might end up with something that might cause a meteor shower, but you don't get a spectacular comet. And we have seen examples in the past of Beazler's comet, I think it is, that came in and was nice and bright, and then the next time there were two of them, and then it didn't return for a third trip. So that's one thing that can happen. And another thing that can happen to comets is they get too close to Jupiter. And if you get close to Jupiter, Jupiter's gravity will mess with your orbit, and they often get shifted onto short period orbits. So a lot of the comets that come back every few years do so because they've encountered Jupiter, and then you boil away pretty quickly. So you might only exist for maybe a few centuries once you're on a short period orbit. So those are your two possibilities. The third one is that you might get slung out of the solar system entirely, again because you got too close to Jupiter, and then you travel through interstellar space, and the odds of you encountering another star are pretty low. Though we do know it now happens because we've seen two objects come from other solar systems and fly through our own.
And Tana, just because you've got the Wikipedia page open, we've got a couple of others I think which are quite suitable, which is Rob would like to know how big is it and how fast is it going?
These are all very good questions, and let me see if Wikipedia can give me the size of it. Oh, I don't know. There's a lot of orbital parameter stuff.
Well, one of the problems you've got.
Comet, though?
So one of the problems you've got is definition of size.
What's the size? So, you can think of it is it the extent of the tails? And as I mentioned earlier, there are two tails. There's a radiation tail and a particle tail, and they exist for various reasons. So the radiation tail always points away from the sun because it's the interaction of, basically, it's the sun kind of melting away the comet. So the charged particles that are given off by the sun in the solar wind interact with this dirty snowball and start to melt it away. And so there's that tail blowing off directly, whichever position the comet is in, that one tail will always point away from the sun. And then there's the other tail that's made up of particles. It's basically the trailing, as it's moving through space, the trailing of bits and pieces of it falling off and melting away. And if you have a good enough picture or good enough telescope or binoculars, you can actually see the two tails separate out. So which tail do you use? The size of the actual dirty snowball, it's hard to get a handle on that. Of Comet, I'm not actually sure of the scales of them.
Right down in the middle, the nucleus for this comet is maybe 1 or 2 kilometers across. So these things are tiny. This is the thing about a comet, is that they're not. If it wasn't for the fact they grew these magnificent tails, which can be hundreds of thousands of miles long in some cases, the nuclei are really small. So there was Comet Churyumov-Gerasimenko, which the European Rosetta probe went and explored, and that nucleus was about 4 kilometers across. So that's about the size of the city, like the very central bit of London. So these things are
that's extraordinarily bright for something so small, isn't it? Because it's not giving off light. We're seeing reflected light.
Right, but most of the light you'll right? So the nucleus is then surrounded by the coma, which is an atmosphere. So you only see them when they're close to the sun and they've grown this atmosphere. And then you've got a shiny cloud of icy particles that are very reflective. So that's what you're seeing. But for example, Halley's Comet, even the biggest telescope in the world can't show you Halley's Comet today, because it must be nearly at the furthest point of its orbit. And it's so faint that we've got no hope of seeing it. It'll be recovered on its way in when it's just a few years away from being in the inner solar system.
Yeah, so you really need that interaction with the nucleus, with the frozen particles and the sun's wind to make it light up like that.
Well, as we're talking about brightness, we have a question from Tommy, and Tommy would like to know why is the moon not always the same brightness? So, who'd like to answer that?
Shall I do the Earth bits, and then we'll let the astronomy do the outside, the external
Don't worry,
bit.
Helen. There's a question about the movie Abyss coming up. That's deep sea. That is very your question. Don't you worry. We know which directions we're going in this week. Okay. We know who's going to go for the up question, who's going for the down, and I know up and down doesn't really exist. But let's
like this. I take the down. Good.
Yeah. And if we ever get to psychological downs, then I will take on those questions. Okay, that's fine.
I love this Venn diagram.
That's why I'm an artist. So Tana, yes, what the moon's brightness?
So the moon changes in brightness, but also sometimes in color. Sometimes you'll have those blood moons, or you'll have, you'll get a halo around the moon, and it has to do with atmospheric conditions. So the atmosphere, the Earth's atmosphere that I mentioned before, it's about 10 kilometers thick from the ground to where outer space begins. And so depending on how turbulent that is, or if there are any particulates or anything like that, it changes the way the light is scattered. So sometimes things will look a bit fuzzy, sometimes things look really precise, like you can go out and it's a cloudless night, but the stars are twinkling a little bit more because the atmosphere moves. That's what, for instance, what wind is. It's moving air. And so you get the different layers of the atmosphere, and there's turbulence. If you get, like I said, if you get particles, then you get the lights in the atmosphere, you get like light scattering. And when you scatter the light, you get different colors coming out. So for instance, there was something in the news a few days ago about all that sand blowing off the Sahara and how it's tracking around the world and all of that. So all of those kind of things, if there's a volcano, if there's sometimes when you get volcanoes erupting, halfway around the world, people will start reporting really gaudy, gorgeous sunsets because of dust and particles and ash and things in the earth scattering the light in different ways, and that affects the moon's brightness as well. And then there's also the fact that the moon is not in a perfect circular orbit around the earth. The orbit changes, so it's not a perfect circle, it's slightly oval, and then it also is tilted. And all those kind of things affect how much light is reflected off the moon that we can see on the Earth as well.
Brilliant, thank you. Now the next question is about making stuff and technology. So I think any three of you will be able to do this, but I'm going to start with you, Chris. This is from Martha. Could you build any sort of home-sized radio telescope, or do they need to be really massive and in a field?
Yeah, well, this is definitely, but we have somebody who works with radio telescopes on the call, but we've got one on the roof of our building. So you can also convert an old school satellite dish, if you've got one of those, into a radio telescope that will let you detect the sun and possibly the Milky Way as well, which are the brightest things in the sky. But you could definitely do this.
Yeah.
So tell me, how would you go about this then?
So what's fantastic about radio astronomy, as someone who's, like I said, I'm an X-ray astronomer, but I've moved a lot into doing radio, is that it's very low tech in terms of the hardware. The complicated stuff really comes in with the electronics when you're trying to build something like the VLA, the Carl Jansky VLA in the US, or the Meerkat radio telescope in South Africa, or the ASCAP telescope in Australia, when you have lots of these kind of dishes moving together. And the magic is in the electronics, but the hardware, you can make a radio telescope out of chicken wire, out of wire hangers. And the trick is to just get them at the right size. So your antenna on your car that catches radio waves, your little satellite dish to help you watch TV. Those are radio receivers. So you can go on the internet and you can Google how to make a little backyard radio telescope and put one together, and you really just need basic stuff. So, but it's going to be a lot of wires, and it's not going to look exactly how you think a telescope, a scientific instrument, is going to look. There's a good chance that it's just strings of wires kind of like banged together. It's not necessarily going to be this perfect dish shape like you see in the beginning of the movie Contact. I'm not sure what the demographics for this audience is, so Contact might not really resonate. For listeners my age and older, we all know Jodie Foster is. They're not going to look like that, but it's basically chicken wire, bits of metal, that kind of thing. You can put it together, and then the electronics is a little bit more complicated. But that's what's fantastic about these radio telescopes, and I've seen them being used in a scientific context. I went to one of my first radio conferences about 10 years ago, and it was in Mauritius. And the Mauritians had decided that they wanted to put something together really low cost and start heading into radio astronomy. And it was just made out of chicken wire, little bits of barbed wire. And they showed us their results, and they saw the Milky Way and the readings that they got and the measurements that they took lined up with published data. So it was all really great. And that's how they decided to progress from there.
And some really famous telescopes of it. So the Mullard Radio Astronomy, the little green men, Jocelyn Bell Burnell, and the discovery of pulsars. I've been to the field, and they bring you to the field, and they say, "This is the telescope," and it looks like washing lines.
Yeah, it looks
because
like
that's what works.
Struts, and then all these just kind of bits of wire going across, and that's all you need to make world-changing discoveries.
But there's an interesting thing here, because I think I admire radio astronomers, because particularly people who build the instruments, because optical astronomers are a bit precious about mirrors and everything has to be precise. And if radio astronomy, because the wavelengths that you're looking at are large, it doesn't matter if things aren't perfectly aligned, or if there's a bolt, or if there's something between your chicken wire. So it's a much more sort of, I don't know,
forgiving, much more forgiving.
Yeah,
there you go. I was going to say it's a little like the way I cook, which is just throwing stuff in and hoping that the result will be the end, rather than any precision.
Are you saying that you can cook at radio wavelengths, but not in the invisible light? Your cooking must never be seen in invisible light.
Particularly good at cooking at microwave wavelengths as well. Yeah,
that's exactly the joke I was hoping you were going to make. It was spot on. I'll tell you about the robustness of radio telescopes and radio observations. During my master's, I was very lucky to be able to visit the Nancy radio telescope, which is sort of in the middle of France. And so for a week, I got to practice my high school level French. I got much better at my French. I got to eat like homemade French food every day. It was fantastic. And I also got to hang out with this radio telescope that is, if it was a dish, it would be a dish about 100 meters across, like you have in Effelsberg or Green Bank telescope in the US. But when it was built, they didn't have the structural engineering prowess to be able to make it into one dish. So instead it was this mirror that was tens of meters across. So when I say mirror, I just mean a few giant sheets of metal with holes drilled in. And then across the field, about 150 meters away, a curved bit of metal. And that was the radio telescope. But because radio telescopes are so forgiving and the wavelengths are so big, you can have small holes, like say a few centimeters across, and that won't actually change how the telescope operates. So the upshot of all of this is that some of the radio telescope operators and astronomers, when they get bored, they would basically practice the golf swings against the reflector. And they would take pot shots at it, because it's nice, because then the balls always come back to you. And so you'd have these little like dents and divots in the radio telescope, but it was still a perfectly well-functioning astronomy instrument, and I got a lot of good data for my thesis from it.
Brilliant. The I'll just mention, by the way, tip jar. which is don't forget, if you're enjoying this and you have a little bit of spare cash, if you can put money in the tip jar, that's fantastic. As you may well have seen, the attempts to bring back live performance, etc., are not going that well at the moment, and we've been building up a resource for art centres and some of the artists we know who have been finding it very, very difficult. And you can also support us via Patreon if that's possible, or if you want something back in return, just go to my Instagram page where I'm selling all my books, and you can buy a book off me instead. It's going to take a while, by the way. I've got quite a few, so it's not going to be an issue. Now I'm going to move to the Abyss question. By the way, I think we need to do a kind of come dine with me with 4 different groups of scientists, because I'd be very interested in terms of biologists, astrophysicists, theoretical physicists. You know, which one are we going to find ourselves
engineers. You want the engineers and the material scientists in there.
I think, yeah. I mean,
although Mark's
material scientists.
At the BBC, there was that Chef versus Science, and it was him and one of the very famous Michelin-starred chefs, and Mark had to make all the things, you know, do all the things without the proper. And the only thing the chef was impressed by, as I recall, was that Mark put red wine in a blender to aerate it, and the chef had to admit that it tasted better. But he said he would never do it because it was not the proper thing to do, and completely missed the point. So
it's good that we're on aerating liquids, because that does bring us very neatly to the question about the Abyss. This is from Anchovy, maybe real name, maybe not real name, who's to tell? And Anchovy would like to know, in the movie The Abyss, they had divers breathing an oxygen supersaturated liquid. Is this science fiction, or is it possible? So, Helen, as you're the person who I'm guessing probably has done the most kind of stuff in the sea, and what is supersaturated?
I'm expert on the Abyss, so I don't know exactly whether they were breathing something that came out of the liquid, or whether somebody put the liquid in their lungs, which sounds like a difficult thing to get rid of. So that would definitely be a bad idea. The thing about oxygen is that, so the reason if you're going to breathe gas, so I'm assuming, not knowing much about the Abyss, that whatever was generating the oxygen, people were actually breathing gas, because otherwise your alveoli would get all bunged up and a lot of things would go wrong. So the thing about oxygen is it actually becomes poisonous if it goes above a partial pressure of about 1.4. So that means that's about 7 times the concentration of oxygen in our atmosphere. So divers get around this by mixing in other gases, but it does get complicated. You have to mix in different gases to balance out the pressures. So you could perhaps use an oxygen saturated liquid to store your oxygen. It would not be a space efficient way of doing it. You could perhaps do it. You definitely wouldn't want to breathe liquid. That's a bad idea. But the problem is not actually you can put oxygen in a tank. It's nice and easy. You can balance it with other gases. The point is not having so much oxygen, it poisons you, which is you go to very, very deep depths, as in the Abyss. You need the gas to both push out on your surroundings and not poison you. And that becomes very difficult with oxygen around below depths of about 140 meters. So I think it would be complicated, and there are better ways of doing things. That's my answer to that question.
So I was just looking at, because I think it's the 3-body problem trilogy by Chinese.
Yes, by the name I can't pronounce. Yes.
Yeah, where they do this, right? So in order to get spacecraft to go to extremely high velocity, but the crew somehow are able to enter a liquid state, which enables them to breathe, but also cushions them against extreme acceleration. It ends badly for pretty much everyone, but at least
the
in
thing
theory,
about that is you couldn't shift the gas through the liquid quickly enough. That's the problem with that, is that diffusion only works so fast. You're on laminar flow when you're in alveoli. They're very, very small. It's a very large surface area. So you basically need layers of liquid to move across the surface and replace themselves. And the problem is you can't do that fast enough. Diffusion of oxygen through the liquid would be very, very slow. And the replacement rate of the liquid would also be very, very slow. So that I think it's a nice science fiction book.
So if you were a species of intelligent fish, you could use your spacecraft, right? So they would be therefore better prepared for high acceleration.
Yes, because their gills are the right shape, so they have one-way flow over their gills, whereas our alveoli are in and out. But even with a fish, it would be difficult because you still have to have quite a lot of oxygen. It's interesting because there's things like tuna, for example, that require a lot of oxygen, that do have very efficient gills. So it obviously works for them, but
so
I'm not sure. Yeah, go on.
I had a bit of a Google, and apparently you can do this with mammals. The trick is to use not nitrogen, because it's something to do with the binding of oxygen to nitrogen. You can't get enough, coming to what you were saying now, you can't get enough oxygen in the liquid so that our lungs can actually get it out of the liquid. So you use something called perfluorocarbons. And then that binds, you can have a lot more oxygen in a liquid, and then you pop that in the lungs, and it does work. So then the problem becomes that you actually, so you can get the oxygen in, then the problem apparently becomes you can't get the carbon dioxide out. And so you do need some kind of mechanical ventilation to help you extract the carbon dioxide. And this has been done in lab experiments on mice. And they even, at some point not too long ago, tried it on premature babies whose lungs are apparently not yet ready for breathing air. But so they were trying to kind of mimic the amniotic fluid that the babies would be dealing with as they were still growing. And that seemed to that's had some positive results, but it's still an extremely complicated intervention that requires a lot of mechanical intervention as well. So only under extremely controlled circumstances is it something that apparently can be done. I was blown away by this because I thought it was going to be a straight no, just like putting liquid in your lungs is always a bad idea. But apparently it depends on the kind of liquid and very, very much on the circumstances.
And whether or not you're
don't
a mouse.
worry, the next question is going to be about James Cameron's view of the time travel conundrums in Terminators 1 and 2. So the rest of the questions are just going to be different science-based questions around James Cameron movies. We may well start with Piranha 2, The Flying Killers, the possibility of the flying piranha fish. But we'll skip all the James Cameron questions we've had sent in, don't worry. I thought because we're quite near the end, we'll just do some nice, easy ones on gravitational waves and also dark matter, because that can always just be knocked out of the park in a couple of minutes. First of all, this is from Melissa. She says, I have a very small and simple question. I don't understand what a gravitational wave is. Now, it is, of course, this was a remarkable, the technology required, the wait for the technology. I mean, that's one of the beautiful things, isn't it? Which is you have almost, it's pretty much 100 years, isn't it, between prediction and detection. So, Chris, I'll start with you and then I'll move.
Sure. So imagine hitting a drum. When you do that, the surface of the drum ripples, and you get those ripples spread out from the point where you've hit the drum. And it turns out space is like that. So if you hit space hard enough, ripples will spread out from where you hit it. And those ripples are what we call gravitational waves. The problem is that space is really stiff. So you have to hit it really hard to get even a tiny wave to move. And so the only gravitational waves we've been able to detect are really tiny, and they're caused by really big things doing dramatic things. So we've detected gravitational waves from the merging of massive black holes, and that causes enough of a bang that you get these ripples spreading out through space.
And Tana, it seems to be one of the problems people have with this is it goes against their instinct. More of it. I don't understand why kids aren't taught from a very early age about the idea of space-time, about this, because I think the way that many of us are taught, they're disconnected ideas, and also the idea of any sense of what you might call in inverted commas solidity or behaving that way. It means that, but when you do eventually come up with this idea, you've had 20 years of education where it feels just too odd.
I mean, even for scientists, it's a paradigm shift, like to get your head around. So we might have to wait to filter into mainstream curricula, because it is complicated when you think about it, because it's these waves. These gravitational waves are not waves that move through space, but the actual waves of space itself. And that's a complicated thing to get your head around. And then it's also, you have things about when you think about it, anything that's moving is changing space. And so me moving around like this, I'm actually generating gravitational waves right now, but you can't detect them because they're so teeny tiny, because space is so stiff. So you have this also this idea that only very, very, very heavy things can change space, but that's not really true. It's about detection thresholds. It's about like, at what point can, and again, this is very anthropocentric because we're saying at what point can we as humans with our current technology detect things? That doesn't mean that they're undetectable to other systems, to other intelligent societies, etc. So it gets very philosophical and meta very quickly. And it's going to take a while before this filters into like I said, into the mainstream and you get taught about it, but we absolutely should. And with the way technology is speeding up right now and the new discoveries coming in astronomy, it's going to be so much fun when you start comparing textbooks from 10 years ago. The stuff I learned at university, by the time I was starting my PhD, was already out of date. I was taught, for instance, that supernovae, so massive explosions of massive stars, for certain kinds of supernovae called type 1 supernovae, that these were standard candles that had a very specific measurable brightness and you could use them. So if you saw them fainter, that meant that they were further away, etc. By the time I started my postgraduate studies, they had been shifted to standardizable candles because we'd learned so much about these things that they're actually, it being fainter doesn't necessarily mean that it's further away. And so a lot of rehashing had to go into this. So things get out of date very quickly. So what we know now about gravitational waves and the 99-year wait is really exciting. It needs to be added into the science textbooks. But in another 10 years, when we've had, because the current gravitational wave detectors are all on the ground, and we're busy working really hard to put one in space to upgrade the ones on the ground. And that's going to be another game changer. And that's in the next 5 to 10 years. And then we're going to have a different kind of conversation about gravitational waves. So it's hard to stay on top of things. And so your learning is, you're learning about everyone's learning about the universe is going to have to change and keep changing because technology is changing so fast and allowing us to know more. So that's really fun. And this is part of the reason why it's so hard to put it in a curriculum if it's going to be out of date in 5 years' time.
But there's a more fundamental point very quickly that I think, which is that the other two might correct me, but as far as I'm aware, gravitational waves are only the third reason we've got to know that the rest of the universe exists. We have light, we have neutrinos, and we have gravitational waves. And if we did not have those three things, we would not know that the rest of the universe was there. So I think there are some very fundamental points about gravitational waves that don't take the complication and the advance, and they're just the most basic thing. We can definitely put that in the textbook.
I think that's right. And it's not as I think we've been biased by light because we are creatures that mostly evolved to experience the world visually. We think that the shiny bits of the universe are most important. And actually, if you pay attention to particles, or if you were a gravitational wave being first, you would think the most important things in the universe are merging black holes. And then you'd only later discover that there's this, these black holes live in galaxies, and maybe some of them come from these shiny things called stars that seem rather insubstantial. And so I think it's a reminder that we shouldn't be biased by what we can see, that our biases are a result of the detection method we use. And that's quite a profound thought.
Yeah. And even comets, as we discussed earlier, comets are another kind of cosmic messenger because, as you said, Chris, there've been 2 visitors to our solar system from another star. So they also carry information. So putting all of this together is what we call multi-messenger astronomy, where you have particles and light and gravitational waves and bits of space debris and rocks, things that fall from the sky and land here, and we can study the makeup of, the solar system. So not the universe at large, but the universe close by, and you put all those bits and pieces together. But yeah, we absolutely are biased by what comes naturally to us and what's intuitive to us. And so stepping outside their comfort zone does require a lot of careful thought.
Right, we've got 4 minutes left. I'm going to see how many of these we're going to get through, but I'm going to risk the dark matter question. This is from Elle. Thanks very much for this question, Elle. Curious on the opinion of the recently observed recoiling electrons. Is this the beginning of the smoking gun of dark matter?
So this was by a dark matter experiment. It's definitely not the dark matter that most of the universe is made of, because the mass of the particles is wrong. But it's still an interesting particle physics result that I'm not going to explain right now.
The next question I'm going to go straight for, which thank you very much for not explaining that. That's sometimes in the last 5 minutes. That's exactly what this Q&A is all about. This is one of the most exciting new images from Solar Orbiter that have been released in the last week from Matt. Tana?
Yeah, it just looks super gorgeous, super detailed. We're learning a lot more about the sun, and you'd think as our closest star, we know, by now we'd know everything we need to know about it, but there's still so much stuff we don't understand, like the magnetic fields and all of that. So yeah, these new images giving us really cool insights, and they just look so pretty, because sometimes astronomers, we get excited about something and then we show it to the world and they're like, really? But this is one of the ones where the excitement matches up with, like, the actual visual representation. So that was really fun.
Kay, thank you very much for your question about gravity. We're going to do that next week, because I've realised there's no way it's going to be able to be dealt with in 1 minute. We've also had a question just on the live chat, which is, where are the best places to go to keep up to date with being able to observe NEOWISE? So, Tana, can I start with you? And where would you recommend people going to check on what we're seeing, what we're discovering, and where to go?
I'm sure they're more local things, but I always point people to NASA first, because they make things very accessible. They have a lot of free resources as well. And so that's what I've been using. And even just an app on your phone, mobile apps like Stellarium, and those kind of things can help, just to point you in the right direction and get you looking where you're supposed to.
One of my friends has NEOWISE app for Apple products, so which will show you where in the sky. Inthesky.org is a really good website that tells you what's above the horizon based on where you are, because all of this is about getting predictions for where you are. So I would use that, and Stellarium, which is also excellent, as mentioned.
And we should mention your book, by the way, because this is also about, some of the very exciting things that happen when you get a large number of people who are not professionals but are interested. The crowd and the cosmos, it's all about the Zooniverse.
Yes, please go and help us out. We've got new galaxies up. So zooniverse.org for people with spare time.
Brilliant. Now, also, I believe that Trent, he sent me a text message saying that he has a show and tell, which is very relevant to today's show. By the way, my show and tell, if you're wondering, is I'm in the room in which I was born in. So there we go. That's my show and tell. I'm pretty much in, not far off, the exact position in terms of, if we use the framing of this room itself and not obviously the movement of everything else around, but where I was born 51 years and 5 months ago. Trent,
hang on, I'm just going to turn myself on because I'm not normally on. I just remembered a weird thing that's relevant that was in the back of our cupboard that I made Mel dig out. My dad found this at a garage sale in Perth about 12 years ago and posted it to me in the UK. It's Halley's Comet whiskey, which he posted that way. And it's rotted. The cork has completely rotted through. It tastes atrocious because it was half drunk when he got it. And he just sent it to me. A little map on the back.
There's a long tradition of Comet wine, because in the 19th century, several of those really brilliant comets accompanied very good vintages in Bordeaux. And so as a marketing gimmick, people started producing wine whenever there's a bright comet. And if anyone makes Comet NEOWISE wine, you can send it to me by a new college in Oxford, and I'll happily certify it as astronomical.
Well, when we see each other next, you can have some of this awfulness.
What alcohol would they like sent free to them? Alcohol or any other drinks that you found some angle to make it look like it's research.
And then we'll do come dine with me. And
perfect.
Reasons.
There is always a warning, isn't there? The moment you have, it's like wine in a really interesting bottle where you go, interestingly shaped bottle. What awful wine! What an interesting connection this wine has to. What awful wine! Whiskey. This is not always true, by the way. In fact, if you'd like to prove your point, you can send that to me. If you want Comet-related stuff, send it to Chris. If it's some other point you want to prove with your alcohol,
chocolate-related, I'll do the hot chocolate tests.
Okay, you do the hot chocolate test. That's great. Thank you very much, everyone, for all your questions. I'm sorry there were a few we didn't get to. Sometimes it's just we run out of time. We're going to be back next. I'm trying to think. Oh no, not well. Next week, it looks like what it's probably going to be is going to be this special event we did from for Blue Dot Festival. I'm still not allowed to announce what it is, but it was a lot of fun. We had a fantastic conversation with someone who you can work out your own way of their connection to Blue Dot. Have fun during the week to work out who it might be, and then we're going to be back the week after for certain with, amongst others, Anil Seth, who is always wonderful on neuroscience. And I did one monkey cage we did on simulation theory was particularly enjoyable because both Anil and myself are not overly keen with wasted time on talking about simulation theory, and I think that comes across in the intonation during some of the questions. The latest monkey cage, I can't remember what it is this week, but we're nearly at Conan O'Brien has just gone up on BBC Sounds. Conan O'Brien, David Eagleman and Gina Rippon talking about the brain. For I think only the second time ever, I think we failed to get to question 1. It always happens when we deal, first of all, with biology, and secondly, most importantly, if we deal with the human mind, rarely do we get to question 1 on that. Thank you very much, everyone, for joining us. The latest one on the radio, Trent reckons, the Radio 4 version, but I would genuinely recommend, if you can, listen to the longer versions on BBC Sounds, the kind of 50, 60-minute versions. We had so much fun. We had Jane Goodall on because it is the 60th anniversary. In fact, it was... I think it was about 3 or 4 days ago, or it might even be. What's the date today?
19th.
Yeah, I think it was 3 days ago. Was the 60th anniversary of Jane Goodall going to Gombe and doing some of the most incredible research in terms of us understanding chimpanzees and ourselves and our journey and our behavior. And as you know, she was an incredible, groundbreaking individual and is still a groundbreaking individual, and someone who was sometimes dealt with quite badly by some of the more officious parts of academia, who attempted to dismiss some very, very important work she did. So she's such an important story, and we had a great time talking to her and others. But thank you very much, Tana. Thank you very much, Chris. Thank you very much, Helen. Don't forget the tip jar. If you can, support us via Patreon as well. We make lots of Patreon-only stuff as well. Go there. Don't forget, on Tuesday, Helen, at 7 o'clock, free to access, and with the engineering awards, and you're going to find the most excitable human being ever on Diggers. Remember, that is the promise. Thanks very much for watching. Keep up to date with all the things we're doing. Enjoy the rest of your week. Bye-bye.